One crucial aspect of using Amazon Web Services is to ensure that we match AWS services with business needs. Now, what this means then is we need to have a proper business needs assessment for a given system. For example, for an internal employee payroll system, or it could be for a parts database linked to a supplier, or it could be a front-end web application that's public-facing on the internet. Whatever the case is, we have to know what we need before we can meet those needs with AWS service offerings. So this means then being familiar with AWS service offerings, of which there are plenty, and also thinking about network requirements in the AWS cloud, compute requirements, storage requirements, including retention of data, monitoring and security requirements, and in the end, making sure that we reduce AWS service sprawl. What this means is that we might have other older AWS services that have been deployed but are no longer required, yet they're still in the background running somewhere. And that can happen because it's so quick and easy to deploy resources in AWS. We want to reduce that sprawl because we want to reduce costs. You pay for things when they are running, whether you use them or not. Pictured on the screen, we have a screenshot of the AWS console. When you click on the services link in the upper left, you get an alphabetized listing of all AWS services, and their categories are shown over on the left. So if you need to see what's available for AWS cost management, or compute, or application containers, or databases, and so on, you can go into each category to drill down to more granular or more specific services within that category. AWS cloud technicians need to be aware of the service offerings. They don't necessarily need to know everything about them. There are way too many of them. But having a knowledge of what's out there means you are better suited to match it to a given business need. And bear in mind that Amazon is adding new services all of the time. So on the network requirements side for a given need, we have to think about how many VPCs, virtual private clouds, that we might need. A VPC is simply a network definition in the cloud. We have to think about how many subnets we would need. Maybe we're deploying a number of Windows virtual machines for testing and also Linux virtual machines for a different purpose for testing. It might make sense to split those up into two subnets, and they could be within the same VPC, if they use the same IP address range, or maybe even one subnet each in a different VPC. You might consider VPC peering, which allows you to link VPCs directly together, which means services can communicate directly using private IP addresses when they talk to one another, instead of going over the internet and using public IPs. You might enable a VPN connection, an encrypted tunnel, to the AWS cloud. For security reasons, maybe if cloud technicians need to remote in and manage a web application running in AWS, they would VPN in to make any required changes. The same goes for managing EC2 instances, whatever the case might be. You might use a Direct Connect private dedicated network circuit, which is a wide area network link to Amazon Web Services, except it doesn't go over the internet. You might want to enable HTTPS connectivity to web services, perhaps even using your own PKI certificate, whether you already have it and you bring it into Amazon Web Services or you generate it within AWS using AWS Certificate Manager. At the network level, we also have to consider network and threat monitoring, using services like Amazon Guard Duty or CloudWatch Network Metrics to ensure things are performing well. On the compute requirement side, we should think about things like EC2 instances. Do we need to manually deploy them to meet a given business need and a workload? When you manually deploy EC2 instances or virtual machines, you have full configuration control of them. You're also responsible for the configuration and patching of everything in that virtual machine. But there are other things. But Amazon also offers managed services, often called platform as a service, which means that, yes, there are some underlying EC2 instances running, but we do not have direct configuration control of them, as we would with a manual EC2 instance that we would have deployed. At the compute level, you might also consider using application containers. Amazon has a number of container services available in the cloud, like Elastic Container Service to deploy containers, Elastic Container Registry to have a centralized repository of custom container images. You can even have container clusters for larger scale, perhaps data analysis types of apps running in containers using the Elastic Kubernetes service. And ultimately, we have to think about storage in the Amazon Web Services cloud, whether it's S3 bucket object storage, so storing files in buckets, or working with databases, whether they are NoSQL or SQL based. NoSQL meaning that we have a less structured schema or blueprint definition for the database than you would with a SQL type of database. NoSQL is really designed for large-scale management of large data sets that might be dissimilar. And of course, storage security comes to mind, where we would think about things like classifying data, perhaps identifying personally identifiable information. We might do that for compliance with certain regulations. We can do data classification with Amazon Macie. And when it comes to encryption of things like S3 buckets, we might stick with server-side encryption using Amazon keys or our own customer-managed keys, again, perhaps for compliance with regulations. When you match AWS services to given business needs and have these things running in the cloud, you need to monitor them constantly, not only for performance, but also for security reasons. You can do this with CloudWatch monitoring. You can also use CloudTrail auditing to audit any changes that might have been made that perhaps are unauthorized. You can use the Amazon Detective service. Amazon Detective is used to identify potential security incidents and to investigate them. You can use network ACLs, access control lists, to control network traffic into and out of VPC subnets, and security groups to control network traffic into and out of EC2 instances. You can use a web application firewall to protect web apps from common threats like SQL injection attacks. And monitoring can also help you align with compliance with certain security standards, whether it's PCI DSS, GDPR, or whatever the case might be. And speaking of compliance, we have a number of privacy compliance standards documentation available on the Amazon website. Here I've got a screenshot of privacy standards for data protection, European Union data protection, GDPR, the California Consumer Privacy Act, all the way down to things like Japan privacy requirements and Malaysian privacy requirements.